Okay, so 4.7 is going to conclude our chapter 4, unit 4. It is on solving systems of linear equations. I'm going to split this lesson up into two videos. One where I kind of go through the skill set that you need, and then the second video will be a word problem, and a word problem that is really going to tie together everything that we've learned, and you're really going to be able to see why we learned everything we did with such a great real world, real application of linear equations. But let's start with the skill set that you need, and that is taking a linear equation and being able to graph it. So far, we know how to graph using a table of values, okay? But we have not learned somewhat a quicker way than a table of values, more efficient way, and that is called the slope Y-intercept method, okay? Because the word problems that we're going to get in 4.7, there's quite a bit of graphing in that all the questions are going to include two lines that we need to graph, okay? Because we're going to be comparing situations, which one is better than the other. And so there's always going to be two equations, and that's where the word systems of linear equations comes in. Systems meaning more than one linear equation, and for us that's going to be two linear equations. Okay, so we need to learn how to take an equation, which we know how to make at this point, and then be able to graph it efficiently. Okay, we already know how to do it with a table. We're going to learn a new method called the slope Y-intercept method. Let's start with just doing a table of values. Okay, so let's say a question was graph the equation y equals 50x plus 200 using a table of values to create your points. Okay, so we're given the equation y equals 50x plus 200. Remember that when you set up a table of values, you make up the x values that you'd like to use. Okay, so these numbers here, okay, you determine which x values you wish to use. In an actual real life application, like what it says right there, is you want to try to use x numbers that are relevant to the question. Now this question here is not a real life application. It's just simply an equation. And so we can really come up with any numbers that we want. And so I chose 0. I would say always choose 0 so you can find out what your initial value is. So always choose 0, but then after that, it doesn't really matter. Okay, so I have 10, 20, and 30. And what I do to create my table of values is I take my equation, okay, of y equals 50x plus 200, and I substitute in these x values that I came up with. So for 0, I plugged in 0 for x, and when I do 50 times 0 is 0 plus 200 is 200. So my first coordinate is 0, 200, and it's already on the graph there. Then I plugged in 10, so my second point became 10, 700. Plugged in 20, and I got 1200. Okay, and then lastly 30, 1700. You can see my answers here, and I just plugged in 30 for x, 20 for x, 10 for x, 0 for x, and then solve the equation to find out y. Okay, so here's my, now I don't have a ruler function here, so I'm going to attempt to freehand draw this line. Okay, so there it is. But of course you would use a ruler. So that's how you do a table of values. Let's now look at this new method that I had mentioned above called the slope Y-intercept method, right there. Okay, so we're going to take the exact same equation, except use this method called slope y-intercept method. Okay, so the equation's still 50x plus 200. Okay, I have written down some steps required to plot your graph in this manner. Okay, I'll do it one step at a time on our graph. So it says step 1 is plot the y-intercept first. Well, what's my y-intercept here? Remember, the y-intercept is the same as initial value. What is it here? It is 200. Okay, so it's always the number that is by itself without the x, right? That's your initial value. Okay, so my point that I'm going to plot on my graph, remember the initial value, the x value is always 0. Remember that. For always with your initial values, it's the value that's right on the y-axis, so it's always 0 for x, and then in this case it's 200 for y. So let's do that first. Let's plot that point first. And actually it's already plotted on this graph right here. Okay, and by the way, let's take a look at my scale here. I know the lines didn't show up great, but it is going by how many lines are in between. It is going by 50s, it looks like. So 0, 50, 100, 150, 200. Then 250, 300, 350, 400, and so on and so on. So it's going by 50s. So make note of that, okay? That you always want to do that when you first look at a scale. Down here, it looks like we're just going by ones. 1, 2, 3, 4, and then 5. I know all the lines didn't show up. I'm not sure why that happened, but going by ones here on my scale on the x-axis and 50 on the y. So I've plotted my first point, 0, 200, and that's just from looking at the equation. Okay, so I looked at the equation and I saw the initial value is 200. Let's go to step 2. Write the rate of change as a fraction. Why can you write the rate of change as a fraction? Well, you know that rate of change is found by doing rise divided by run. So in this case, my rate of change is 50. And actually, I wrote it down here anyways. So 50, remember, any whole number, if you were to write a whole number as a fraction, it becomes 50 over, well, any number over 1. So if I were to write 50 as a fraction, it becomes 50 over 1. And that means that if the formula is rise divided by run, then the rise, which is in the numerator, would be 50, okay? And the run, which is in the denominator, would be 1. So basically what that's saying is that I am going up 50, a rise of 50, and then write 1 unit because my run is 1 unit. So I go up 50 units, write 1 unit. That's my rate of change. That's how the points are changing in my graph. Okay? So how does that look like on an actual graph? Well, step 3 says from your y-intercept drawn on the graph, so from the y-intercept, move up 50 units and then write 1 unit on your scale. Okay? So from my y-intercept, go up 50, right there, and then across 1 unit. It's really hard to kind of draw that small. Okay? It's pretty hard to draw that small because my scale is going by 50s. This is going to be a little bit sloppy. Okay? And that's why at the bottom here I have a tip. When you feel like your scale on your axes just isn't large enough, or small enough, I should say, to accommodate your slope, your rate of change, we can actually change that fraction. instead of 50 over 1, okay, instead of 50 over 1, what if we used bigger numbers? Because my scale seems to be larger here, okay, because I'm going by 50s, it's a pretty large scale. What if I used bigger numbers? How can I write 50 over 1 as a bigger number? Okay. And remember, I want to do this just because my graph's going to be too sloppy because my scale is just too big to accommodate. My scale is just too big to accommodate this 50 over 1 rate of change. Okay, so if I go down, how can you change 50 over 1 to be a larger fraction, but still an equivalent fraction? Well, you can take your numerator and multiply it by a number. In this case, I went from 50 to 100, so I multiplied by 2. And as long as you do that to the denominator as well, whatever you did to the numerator, you do to the denominator, you've created an equivalent fraction that is larger than the original. Okay? And you can do an even bigger one. So how about you multiply the top by 10 and you just multiply the bottom by 10? Wouldn't it be nice now to use this fraction, 500 over 10, as opposed to 50 over 1 on my scale? Watch how much better this will turn out for my line. Okay, so let's scroll up. So now I'm going to use the rate of change. Instead of 50 over 1, I'm going to use 500 over 10. I basically made the fraction 10 times larger. So now my rise is 500 units, and my run is 10 units. Okay? Because it's rise divided by run. 500 divided by 10. So I'm going to go up now. 500 from 200. So let's try this. Here's 300. So I'm going to go up 500. So from 200, I'm going to go all the way up to 700. I'm doing a rise of 500 units. And then I'm cutting across 10. So right up here, just going to make a mark here. So I went up 500 and I went right 10 units. This is where now your new point will be. Okay? That's where your new point will now be. And so now all you really need is 2 points to draw a line. I can now draw a line very quickly and easily. If you get good at this, this is much easier than a table of values. Okay? It's much, much easier than a table of values. Because what did I ultimately do? Well, just by looking at the equation, I plotted the y-intercept right here. Okay? And then from there, I looked at the rate of change, and I saw the rate of change was 50 over 1, which I changed to be 500 over 10 just because I felt like it would work better with my scale. So I went up 500, and I went right 10. And I got to my next point. And from there, I was able to draw a line going through those 2 points. And that was it. Much, much quicker than a table of values if you get good at this. Okay? And you can continue to draw more points. Now, if my graph was big enough, from this point here, I would just go up another 500 and then another 10 going this way, and then draw my new point. So from each point, you keep going up 500 and right 10 from each point. Okay? So you can just continue to draw as many points as you really want as long as your grid is big enough. Okay? So the steps are here. All right? We did all of these steps, by the way. I just kind of talked you through all of them. Okay? But one of the things that we did was I looked at my scale and I saw that a rate of change of 50 over 1 was just going to be too congested. Like going up 50, right 1, up 50, right 1. It just would have been a little bit too hard to draw, right? Like it would have been like, especially my pen isn't the easiest to write with on this grid. So it just would have been too hard to do. So I changed the fraction to 500 over 10, which is an equivalent fraction. And I was then able to draw my next point a lot more clearly. And it doesn't have to be multiplied by 10. We could have multiplied it by 4, right? So how about this? How about going from 50 to 200, multiplying it by 4? Whatever you do to the numerator, do to the denominator. I could have used this fraction as well. All of these fractions are the exact same. They're all the exact same. It doesn't matter which one you use. Use whichever one is easier to graph. Okay? And actually, I probably would have gotten more points in if I used 200 over 4. And why don't we practice that? And just to get the hang of this, let's do 200 over 4 instead of 500 over 10, just to kind of get the hang of it. Okay? So let's put our y-intercept. I am now going to use a rise of 200 and a run of 4. Okay? So let's go up 200. Okay, from 200 to 400 is my rise. Okay, so I go up 200 and then I run a total of 4. So 4 would be to right about there. Draw across. There's your new point. Okay, from there, so that's up and to the right. Now from there, let's draw another point. So go up 200 more and go to the right 4 more. So this time we're going to be at 8. You can draw another point. Okay, so we keep going. Oops. Okay, sorry about that. So we keep going up 200, right 4, up 200, right 4, up 200, right 4. And then you can draw your line. You can see that staircase. Okay. Do you have to draw these lines here? Absolutely not. You don't have to draw them. I'm just drawing them to show you that I'm going up 200 and right 4. But you absolutely don't have to draw them. You can just kind of eyeball it of where your next point will be. You don't have to draw those lines. Okay. This is the exact same line that we drew before as the 500 over 10. Okay. It's an equivalent fraction. It's the exact same line that we drew. Okay. So you can see how quickly and easily you can plot graphs when given an equation if you use this new slope y-intercept method. That's going to conclude part 1 here of this lesson. I will now do in another video, I'll do the word problem that goes with this lesson. And it's a fantastic word problem that